let me show you how to run the CMap software on your own computer. Actually, it is very similar to the steps when you run it on Colab, but it is more faster and save your time if you have it on your own computer, because you can modify the process number, modify the code, and other things more quickly. First, we need to set up the conduct environment for this project, and let's use conduct to do that. Environment. Please be careful. The touch version should be compatible to your computer driver, and maybe you need to modify it by yourself, the touch version and other things. After you have configured the environment, Python environment, and you should use the environment here to select your local configured environment and then run it. It is composing the 2D slides into 3D volume depending on the resolution you give. And here is the XYZ resolution. And remember, if you are running on your own data, you need to modify your parameters depending on your image. Here is the number slides, and here is the how many slides you have for one embryo at one time point. Here is the embryo length, and here's the max times, and as well as the resolution, Z resolution. And the non-dictionary path should not be changed because it will be updated automatically, and it will be saved again in here, and which will be used in the following running process. And let's go down, and I think it's very clear for you by reading this explanation. So let's go to the training part. Let's stop it if we don't use it. Yes, and here's the training part. And if you are running on your own training data, you should modify the configuration file here in the experiment and the train text. Here modify here lists the train embryo length and the train max times. You don't need to have a consistent time time point for one training embryo, it will read it automatically. You just need to make sure the max time have already over the real training embryo you have. For example, here for this embryo, we have the max times for it is 93, and then you put a number larger than 93. That's fine. And the data set and out of this, if you want to change the training or the network configuration, change it here. And of course, you can change it here by using the args dot and the variables name. Here is reading the configuration file. And go through it. Here we read the network name and load it from the module and run the block one by one. Here we start to train. The training time depends on the epoch as well as epoch number as well as your training data length. For the training data for the example of training data, we have 54 volume, 3D volume, and we change it for 100 epoch. It costs about 30 minutes. And the training message will be solved at the log. And you can find it. The configuration file is then train text. So the training log is here. And here's the loss, iteration number, epoch number, and the loss. You can check it and whatever you want, wherever, if you want to see what's the loss. If you are running the program on your own computer, as you can launch the restore. Then show you restore. Yeah, and here is the user restore module for visualization. You can check it how to launch it and use the web to modify to monitor the training process. And I think the training 100 epoch training will cost you about 2 hours. So you can change it. You should change it until they finish, and let's go to the next part. Let's shut it down. Let's run segmentation. Here, the same process as the training. We load the module and as well as the setting. And after your chain, you have already get the chain model here, epoch here, and you are loading the chained model here. You can change it to your path where you put your model and go through it one by one. And this block is predict the Euclidean transform distance. Membrane cell is predicting the cell membrane. So let's waiting because there are two embryo, and the first embryo mass time is 180 and the second embryo is 187. So let's wait for it finished. And yeah, I will not wait it finished because you can see here it will cost 5 hours and more than that, depending on how many process you use here. And after we get the cell membrane, we will run the function to transform the cell membrane to the cell instant using water cell segmentation algorithm with the cell nucleus position seeding. You can see here it costs 2 hours for one embryo and 2 hours for another embryo. So let's go to the next part. And for reminder, the cell shape analysis will cost more time because it is building a alpha shape on the cell object to estimate the cell instant surface area. So you should run it with patience, and you can see here it costs 48 hours when I'm using 30 process, and 46 hours for another embryo. It is 5 days. So you should, if you want to run it, you need a computer that can be standby. So and you just run it one by one, and you can check the output in the following thing. And here we generate the nucleus location file, and also compose the cell volume, cell surface, and the cell content surface area into one CSV file, which can be opened with your Excel. And at last, after we go through the previous 4 notebook, we will run the last one to compose them into the formatted GUI data, so that we can use the ITK CVE snap to open that, which allowed us to have a good 3D visualization on the whole data. And this notebook takes less than 10 minutes, and you can check it how many times unique here for each block. After all of that, you can find it the output is here, and here's the GUI data, and you just need to download the software we provide and open it, and that's it.